Let's try another one. This one is x squared plus 11x plus 24, and it wants you to factor. So the first thing I write down is that our values m plus n are going to give us 11 because it corresponds with the b coefficient here. And m times n is going to be equal to 24. So again, same way as last time, let's start with the factors of 24. We just did this, so it shouldn't be that hard. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now which ones add to 11? So we're going to look at the sums of all of these. 25, 14, 11, and 10. So we look at what two values multiply to 24, it would be all these, and add to 11. Not 11, not 11, 11. So we write with our open parenthesis first, x plus 3, x plus 8. And then, as always, when we can in math, we want to double check our work, so let's FOIL this out. First, it's going to be x times x, which is x squared. Outside is going to be 8x. Inside is going to be 3x. And last is going to be 8 times 3, which is 24. Combine like terms. So x squared plus 11x plus 24. That's what we started with. That checks out. And so x plus 3, x plus 8 is going to be the solution when you're asked to factor x squared plus 11x plus 24. This next problem is very similar to the ones we did before, the only difference being that instead of telling you to factor the following, it says solve. And that's just going to add one extra step at the end that involves the zero product property that we talked about. So start just like you would normally, and we're going to try and find an m plus n that equals 12 and an m times n that equals 32. So we need to find two numbers that multiply to 32 and add to 12. So since we need to find numbers that multiply to 32, we'll find the factors of 32. Maybe 1 and 32, 2 and 16, 3, that doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7 doesn't work, and we're up to 8, so that means we're done. And now we have numbers that multiply to 32, and we need to find which ones add to 12. So we'll make our sums column here. 1 plus 32 is 33, 2 plus 16 is 18, 4 plus 8 is 12. So we need two numbers that multiply to 32 and add to 12. That's going to be these guys right here. Open parenthesis, x plus 4, x plus 8. And now, normally this would be the end of the problem if we were just factoring, but because it asks you to solve, you then have to set this equal to 0, which is because of the zero product property, and then solve for each separate case. So we have x plus 4 equals 0, and x plus 8 equals 0. Subtract the 4 from both sides to get rid of the 4, and you have x equals negative 4. And subtract an 8 from both sides, x equals negative 8. So when you're asked to solve a quadratic formula, you'll have two values that satisfy it, whereas when you're asked to factor, you find these two factors of a quadratic equation. The next example we have to work on is going to involve some negative numbers, which isn't too much more difficult than what we've been working on, but there are some other things that you have to think about, and it does take a couple extra steps to get to the same kind of solution. So let's just get into it. So the first thing we notice is that it's in our regular standard form, and what we have to do is we find that m plus n is now not just going to be 6, it's actually going to be negative 6, because usually our coefficients have been positive, but in this case it's a negative, and so that is important, so we must write that this way. And also, the m times n is going to be negative 16. So we need to find two numbers that add to negative 6 and multiply to negative 16. So first I'll start by listing the factors of 16 just as normal. So we have 1 and 16, 2 and 8, let's see, 3 doesn't work, 4 and 4. And that is all the factors of 16. So now we need to check if any of these multiply to negative 16. So to get to negative 16 here, we can see that we'd either have to change the 1 here to a negative or the 16 to a negative. So we're going to have multiple cases. So we could either have negative 1 times 16 or 1 times negative 16, negative 2 times 8, or 2 times negative 8, and negative 4 times 4, or 4 times negative 4. These all equal 16, negative 16. But what do they add up to? The sum is where the differences comes in. Okay, so negative 1 plus 16 is going to be 15. And 1 plus negative 16 is going to be negative 15. Negative 2 plus 8 is going to be 6. And 2 plus negative 8 is going to be negative 6. Negative 4 plus 4 is 0. 4 plus negative 4 is 0. So now we need to look at what we needed. We needed two numbers that add to negative 6 and multiply to negative 16. All these are factors of negative 16. But we only have one set of numbers right here that gives us the negative 6 we wanted. So, just as usual, open parentheses, x plus 2, since that's positive. And here our difference is going to be, since this is minus 8, it'll be x minus 8 to finish the solution there. And because we can, let's make sure our math is correct and check by using FOIL. So first, it's going to be x squared outside minus 8x inside plus 2x, and last, negative 8 times 2 is negative 16. Combine our like terms, negative x plus 2x is a minus 6x, and that's 16. We check, does this correspond to this? They match up identically. So the final rewritten solution will be x plus 2, x minus 8. I also wanted to talk about some of the different kinds of problems you might see. So instead of asking you just a simple, here's a quadratic formula, now I want you to factor it, sometimes they'll throw in something a little bit tricky that just involves one extra step, or sometimes maybe two, and it's just to algebraically make the expression equivalent to 0. So for example, number 5 here, it says x squared plus 4x equals 45. Now that's not in our standard form of ax squared plus by equals c, so before we factor this we need to make it that way. And algebraically we can do that by subtracting 45 from both sides so that we'll have 0 on the right. So let's just go ahead and do that. So you get x squared plus 4x minus 45 equals 0. And now this is just like your standard quadratic factoring problem. So our m plus n is going to equal 4, and our m times n is going to equal negative 45. And so let's start by putting the factors of 45. Okay, we have 1 and 45. 2 doesn't work. 3 and 15. 4 doesn't go. 5 and 9. Let's see. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9, and that means that's all of them. So now we have all the we have 3 sets of 2 numbers that multiply to 45. So we need to find the sets that add to negative 45, since that's the c value that we're looking for. So this would be negative 1 times 45, or 1 times negative 45. This would be negative 3 and 15, or 3 and negative 15. And here we'd have negative 5 times 9, or 5 and negative 9. And we need to find our sums because we are looking for a value that will add to 4. So negative 1 plus 45 is 44. 1 plus negative 45 is negative 44. Negative 3 plus 15 is 12. 3 plus negative 15 is negative 12. Negative 5 plus 9 is going to be 4. And 5 plus negative 9 is going to equal... Sorry, I stopped right there because I saw the number I was looking for, but 5 plus negative 9 is going to be negative 4. And the values we were looking for are here, because we needed to find 2 numbers that multiply to negative 45 and add to 4. So, since this is a negative 5, we'll write it as x minus 5, x plus 9. This problem asks you to solve, so you don't stop here. This is just factored. To solve, we have to use a zero product property.